Let's take a quick look at your button debouncing code. So go ahead and call it up. When we get down into the button press loops, where we go back many dozens of times to see if the button is pressed or released, you probably played around with this number right here, 50. The smaller that number got, the more erratic the counting got, because now you were going back and reading the button so fast that the processor could literally count button bounces. But if you make that number too high, it slows down the responsiveness of the circuit. For example, if you set that to 255, the processor wouldn't even count up one unless you sat there and held the button for 255 check cycles in your program. So you want to refine this number and experiment. That's smart programming. Program it, try it out, see how it performs, make changes, etc. Now, this particular program only refers to that number like twice, but you will find yourself writing programs, especially when it comes to timing things and setting up delays, where you want to fine tune a delay and you make that delay like 10 times in the same program. So I can manually go through the program and hand change every single instance where I set the count to 50. Now it's a pain, especially if you've got 10 instances of that same number scattered throughout your very long program. Now, if we were writing in straight machine code, that's what we would have to do. We would have to keep track of every single instance of where those delay numbers were in the program and go back and change every single one of them. However, we are programming in a programming language, the assembly language. As a result, we have a compiler which translates our assembly language into machine code for us. So all programming languages, C, C++, BASIC, Fortran, you name it, all programming languages have a compiler, basically a program, which translates your program into machine code. So we can put that compiler to work for us to make our programming life just a little bit easier. We can declare a variable. You know how in mathematics called algebra, you can have a letter represent a number. Now you may know the number, you may not. The point is a letter can be used in place of a number. Well, it's the same thing here. We can tell the computer, hey, I'm going to use this letter combination to represent this number. So now, as I write the program, every time I use that number, which I'm going to change often, I instead write in the variable of del. Now this can be any combination of letters and numbers, again, as long as it doesn't match a command or a label you already created. And remember, these are case sensitive as well. So in my case, I declared to the compiler. When people declare something, what are they doing? They're telling people. So we're telling the compiler that throughout this program, the capital letters, del, equal 50. Now, as I'm writing the program, every time I refer to that button count, I put in the capital letters del instead of 50. The advantage is now is that all I have to do when I tweak the delay is change one number. I changed the value that was declared for del, and the compiler now replaces del with my new number in every single instance of the program, of my entire program. Now, for this example, it's not a big deal because you only have 2 instances in our entire program. But if you make a lot of instances, or you make that change like a dozen times or something, then it quickly becomes worth your time to declare a variable and use it. In the next program lesson, you are going to write your own program, and we're going to call delays throughout the whole program. So I'd recommend making some variables. Remember though, lowercase del is a different variable than the uppercase del. Now you can do that if you want, though I wouldn't recommend it. But you can make 2 variables the exact same, only one's got a capital letter or multiple capital letters, and so it's a different variable than the other one. Now this can really throw some confusion into your program, so it's your program. You can do what you want, but I wouldn't do that. This also opens the door for a real easy mistake to be made. Let's say you used your name for a variable. And when you declared it, you made it all lowercase Andrew. But then in your program, by force of habit, you capitalized the first letter without even realizing it. You go to compile and you get this dreaded error, symbol not previously defined. Also, your variable can be a single letter if you want. Just keep track of what each letter is used for in your program. Back in the days of the VIC-20, you made use of every single byte of memory. You had to because you only had 2,000 of them. So the majority of variables I used were actually a single letter. Now, you don't have to do that because your variables are stored on your PC. They're not stored on your PIC, rather they are stored on your desktop computer. And the compiler converts it into machine code for you. And it's the machine code that's stored on your PIC. So go ahead and make your variables as short or as long and descriptive as you'd like them to be. In the next program where you write, we'll go over troubleshooting, and this is probably the most common error you'll encounter. It can be something as simple as an inadvertently capitalized letter.